Okay, today we will cover paper 2 past paper questions related to chapter 11 acid and bases. Let's get started. Before starting the questions, you need to remember these basic concepts, or you can say the definitions that are related to this chapter. The first definition is about acid. What are acid? Those compounds that release hydrogen ions in the solution. Okay, even if the acid is a weak acid or it is a strong, it will still release the protons or hydrogen ions. Okay, what is base? Base is a substance that neutralizes the acid, and it includes both metal oxides and hydroxides. And what is an alkali? Alkali is actually a base that is soluble in the water. So any soluble base in a water is called alkali. What is neutralization reaction? The reaction between acid and bases is called neutralization reaction, in which the product is a salt and water. Okay, let's see now about the pH scale of acids, alkali, and the neutral compounds. The pH of the acid is always less than 7, whereas the pH of the neutral compounds like water is always equal to 7. Alkalis have a greater pH than 7, from 8 to 14. If any compound has a pH, they are alkali. Okay. Now let's come towards the indicators. How we can know that this particular compound is an alkali or it's an acid. We have some specific indicators for them. If we use a litmus paper, it usually give red color in the acid, whereas in alkali, it will give you a blue color. Another indicator that we can use to identify the acid and bases is phenolphthalein. It's colorless in the acid, whereas it gives you a pink color in alkali. Let's come to our methyl orange. Methyl orange color changes to red in acid and it changes to yellow in the alkaline solutions. Okay, let's see first question. In which reaction does an acid react with a base? Let's see one by one each of these options. Dilute sulfuric acid is added to a piece of magnesium ribbon. So sulfuric acid is reacting with a metal and you will not get a salt over here. So it's not an acid-base reaction. Let's see about the option B. Dilute sulfuric acid is added to aqueous barium chloride, producing a white precipitate of barium sulfate. Again, barium chloride is not a base, it's a neutral salt. So it's also not an acidic base reaction. Let's see option C, aqueous sodium hydroxide. Sodium hydroxide, we already know that it's a base, is added to aqueous copper sulfate, producing a blue precipitate of copper hydroxide. So copper sulfate is also a salt, but it has some acidic properties. So this one is giving you a blue precipitate salt, another salt. So this equation is actually a neutralization reaction, or you can say an acid-base reaction. So option C is the right option over here. Let's see question 3. Which row describe the properties of an acid? So acids are always proton donor. We already have covered this in definition, and their pH is always less than 7. So which option is right? Option C. Question 4. Which row describe an acid and an oxidizing agent? An acid, again, we already know that it's a proton donor. Hydrogen ion will be donated by the acid. So proton donor, C or D option can be right. And what is oxidizing agent? We already know oxidizing agent are those compounds that are reduced. So which one is reduced? The one which will accept the electron. So oxidizing agents are actually electron acceptors. So option C is the right answer for this question. Question 5. Which statement about acid and bases is correct? A base is a donor of hydrogen ions. Again, wrong. Base is an acceptor of the hydrogen ions. Acid is the donor. So an acid is an acceptor of proton. Again, wrong. A strong acid is fully ionized in aqueous solution. Yes, that's right. Question 6. Ethanoic acid react with water to produce an acidic solution. Which row describes the role of ethanoic acid and water in this reaction? Remember that ethanoic acid is a weak acid, but the property of the acid is always that they donate the proton. Okay, so it will remain the same. It will donate a proton. So option C is the right option over here. It donates a proton. And water, of course, will going to accept that proton. So option C is the right option over here. Question 7. What is the characteristics of acid? Okay, acid turn methyl orange indicated yellow. Wrong. It's the base turn methyl orange indicated yellow. You have to memorize these things. Acids have a high pH value. Again, wrong. They have low pH. Acid react with ammonium salts to give ammonia gas. That is also wrong. Always the bases react with ammonium salt to give you ammonia gas. Okay. Acid reacts with carbonates to produce salts. Yes, that's right. All the acids, even if they are weak or they are strong, whenever they react with carbonates, they will produce salts. So option D is the right option over here. Question 8. What is not a typical characteristics of acids? They react with alkalis producing water. Yes, right. They react with all the metals producing hydrogen. This is not right. They react with the metals, but not all the metals react with the acids. For example, the copper does not react with the acid to produce hydrogen. Okay, so that's why B option is not right. Question 9. Which statement about acid is correct? A strong acid has a higher pH than a weak acid of the same concentration. Wrong. Acids always have a pH less than 7. So if their pH is around 0, 1, or 2, it means they are strong acids. So their pH should be lower than the weak acid. A strong acid is a proton acceptor. Again, wrong. Acids are always proton donor. A weak acid is a proton donor. Yes, right. Acid, whether it's a weak or it's a strong, it will always be a proton donor. So option C is the right answer. Why not D? Because a weak acid partially ionized in aqueous solution, not fully ionized. Okay, so option C is the right option here. Question 10. Which statement about acid is correct? Acids are proton acceptor. Wrong. Acid transfer electron to base in aqueous solution. Again, wrong. They transfer the protons to the bases. Hydrochloric acid reacts with ammonium hydroxide to produce ammonia. Again, wrong. Hydrochloric acid is an acid. Acids don't react with the ammonium solutions to produce ammonia. Only the bases can produce the ammonia gas. Okay, so now let's see option D. Ethanoic acid partially ionizes in aqueous solution. Yes, that's right, because ethanoic acid is a weak acid, so it will partially ionize. So option D is the right option here. Question 11. Which statement about acid is correct? A weak acid partially dissociates in aqueous solution. Yes, that's right. So option A is the correct option here. We don't have to look for the other options. Question 12. Burning fossil fuels release sulfur dioxide, which leads to acid rain. Which ion in the rainwater cause it to be acidic? Of course, whenever sulfur dioxide react with the water, it produces sulfuric acid, and sulfuric acid, of course, is a proton donor. So it will always release proton. So option A is the right option here, proton hydrogen ions. Okay, let's see question 30. The equation shows a reaction between aqueous hydrogen bromide and aqueous ammonia. Which statement describes the role of aqueous hydrogen bromide? So if you see in this equation, hydrogen bromide is in the reactant, we have HBr, but in the product, we have just bromide ions. It means the proton, which is hydrogen ion, has been released and it has been accepted by ammonia. So it means hydrogen bromide is acting as a proton donor here because it has donated its proton to ammonia. So option D is the right option over here. Let's see question 14. Hydrogen chloride gas reacts with water to produce an acidic solution. The equation for the reaction is shown over here. So which statement describes what happens during the reaction? First, the chloride ions is formed by accepting an electron from the water. Chloride ions are formed by accepting an electron. Wrong, because it was already a chloride ion over here, right? The hydrogen chloride loses an electron to form the chloride ion. Again, wrong. It was already a chloride ion here, right? In the hydrogen chloride. Let's see option C. The water accepts a proton from the hydrogen chloride. Yes, that's right, because the water has accepted the proton, or you can say the hydrogen ions from the hydrogen chloride. So option C is the right option over here. Question 15. Potassium hydroxide is a base. Which statement describes a reaction of potassium hydroxide? Now let's see one by one. Chlorine is formed when it is heated with ammonium chloride. Okay. So chlorine is formed when it is heated with the ammonium chloride. That's wrong. Chlorine is not formed. Okay, we always guess ammonia. So it turns universal indicator green. Again, wrong, because potassium hydroxide is a base. So mostly the color will be a purple color. It reacts with an acid to produce a salt and water. Yes, this option is right because it's a base. So whenever it will react with an acid, it will produce salt and water. So option C is the right option here. Okay, let's see question number 16. In which equation is the underlined reactant acting as a base? So first of all, we have here H3O plus and in the product it becomes water. So it has already donated one proton, that is hydrogen ion. So it's not a base. Ammonium ions, it is converted into ammonia, already donated one proton. So it means it is also not a base. The base will accept the proton. So this is a water molecule. The water molecule in the product has changed to H3O plus. It means now it has one more hydrogen ion. So it is actually accepting the proton. So water molecule, the option C is the right option. It is acting as a base over here. Okay. So option C is correct. Let's see question 17. Which statement explain why lime is added to soil? What is lime? Lime is actually a base. So lime is CaO, calcium oxide, or you can say CaOH into 2. So why we will add it in the soil? If the soil will be acidic, then we have to add the base, right? To neutralize it. So that's why it means the pH of the soil is acidic. So we have to increase the pH of the acidic soil, because if it is decreased, that's wrong, because acidic already have the decreased pH. So to increase the pH of acidic soil, that's option C. So that's why it's right. Question 18. Ant sting hurt because of methanoic acid produced by the ant. Which substance could most safely be used to neutralize the acid? So now we have to use a base that can neutralize it. So the base, which one will have the pH more than 7? So we have two base over here, baking soda and oven cleaner. So baking soda is the most safe option here because it is mild base. It's not a very strong base like oven cleaner. Okay, so we cannot use this one because the pH is 14. It's a very strong base, so it will affect our skin. So it's better to use the baking soda. So baking soda, option A is the right option. Question 19. An aqueous solution of copper sulfate was made by adding excess copper oxide to dilute sulfuric acid. The mixture was heated, stirred, and then filtered. What was the pH of the acid before adding the copper oxide and of the solution after filtration? So now let's see. The acid pH, of course, it should be lower than 7. So C or D option will be right. Before adding copper oxide, the pH was less than 7. And after adding copper oxide, of course, it was acidic base reaction. So there was a neutralization reaction. So now neutralization reaction means the pH will be almost near to 7. So option C is the right option over here. Question 20. The graph shows how the pH of soil in a field changes over time. At which point was the soil neutral? So neutral means the pH of the soil should be 7. So can you see where we have 7? Of course, at the point B. So point B is the right answer over here. Question 21. Carbonic acid is a weak acid formed when carbon dioxide dissolved in water. What is the pH of the solution? So carbonic acid, of course, it's a weak acid. So its pH should not be as lower, that should be near to 0 or 1. So it should be around near to the neutral one, like 7. Okay, so we have to find that one. So for this one, the option B is the right option because the 5 is still acidic, but it's a weak acid. Okay, so option B is correct. Let's see question 22, which row shows how the hydrogen ion concentration and pH of ethanoic acid compare to those of hydrochloric acid of the same concentration. So we have to compare the concentration and the pH. So ethanoic acid is a very weak acid, whereas hydrochloric acid is a very strong acid. The strong acid completely dissociate into ions in the water, right? But the weak acid will partially dissociate. So it means the ions of hydrogen ions will be in lower amount or in lower concentration compared to that of hydrochloric acid. So C or D option can be right. Now let's see the pH. What will happen to the pH of ethanoic acid compared to that of HCl? HCl is a very strong acid, so it means its pH should be around 0 or 1. Ethanoic acid is a weak acid, so its pH will be higher than that of HCl. So of course, compared to HCl, the pH will be higher and the hydrogen ion concentration will be lower. So option C is the correct option here. Question 23. A sample of ethanoic acid and a sample of HCl again have the same concentration. It's the same question that is having a different wording. So same, the answer will be same. The hydrogen ion concentration will be lower and the pH will be higher for ethanoic acid. Okay, so option C is correct. Let's see question 24. Two acid P and Q with the same concentration and volume are reacted separately with the same mass of magnesium ribbon. The reactions produce the same total volume of hydrogen gas, but acid Q reacts much more slowly than acid P. Which explanation for the difference between P and Q is correct? One of them is a strong acid and the other one is a weak acid. So let's see. The reaction produces the same total volume of hydrogen gas, but acid Q reacts much more slowly. So it means acid Q is a weak acid, right? Whereas acid P is a strong acid. Let's see if we can find these options. Acid P has a higher pH than acid Q. Wrong. Because acid P is a strong acid, so its pH should be lower. Acid P has a lower concentration. Again, wrong. Acid Q is partially dissociated and acid P is fully dissociated. Yes, that's right, because acid Q is a weak acid and acid P is a strong acid. So option C is the right option over here. Question 25. Solution of acid R and acid S have the same concentration. The same volume of each acid at the same temperature is reacted with the same mass magnesium ribbon. The volume of hydrogen gas produced is measured. The results are shown over here. So it's the same question like question 24. You can see the graph. In the graph, R and S are both are producing the same volume of hydrogen. You can see over here, right? But S is much weaker than the R. If you see, the S slope is less steeper as compared to the R. So the reaction is faster in R compared to S. So what does it mean? It means acid R is more stronger than acid S. So let's see now one by one. Acid R is stronger. So acid S reacts faster. Wrong. Acid S is reacting slower. You can see over here, the slope is down. Whereas for R, the slope is more steep. So R is more reactive. The final volume of hydrogen gas produced in each of the reaction is different. Wrong. If you see, the line is, both the lines are here, they are combining with each other, right? So it means the volume of the hydrogen gas is equal. Acid R is a stronger acid than acid S. Yes, R is stronger than acid S. So option C is the right option over here. Question 26. Which solution has the lowest pH? Okay, so we have to look for the pH of all of these solutions one by one. And remember that the lowest pH will be of the strong acid. So we have to find the one which is a strong acid. Ammonia solution. Ammonia is a base, so it's rejected. Ethanoic acid, it's a weak acid, so it can be an option. Lithium hydroxide, again, it's a base. Nitric acid, this one. Nitric acid or ethanoic acid, one of them has the lowest pH. Which one? Of course, the nitric acid, because it's a strong acid, whereas ethanoic acid is a weak acid, so its pH will be near to 7. Whereas nitric acid will be, its pH will be near to 0 or 1. So D option is the right. Question 27. Which row shows the difference between a weak acid and a strong acid? So weak acids, they partially ionize, whereas strong acid, they fully ionize. So option D is the right option here. Question 28. What is the definition of strong acid? So acid is a proton donor, right? So a proton donor, COD can be right. Now let's see what is the next statement. That is completely dissociated in aqueous solution. Yes, that's right. So a proton donor that is completely dissociated in aqueous solution is a strong acid. That is C. Question 29. 4 statements about strong acids are listed. Which statements are correct? So now let's see one by one. They react with carbonates to form carbon dioxide. Yes, right. They completely dissociate in aqueous solution. Right. They react with ammonium salt to produce ammonia. Wrong, because always the bases will react with ammonium salts. They are proton donors, not acceptors. So only statement 1 and 2 is right. That is option A. Let's see question 30. Which statement about strong acids are correct? First, they have high concentration of OH ions. That's wrong. They have high concentration of hydrogen ions. Second, they have a pH value of 1. Yes, that's right, because acids have a pH value less than 7 and strong acids have a pH value near to 1. They completely ionize in water. Yes, that's also right. They turn red litmus blue. That's wrong. They turn the blue litmus red. So we have second and third statement that is right. So option C is correct. Let's see question 31. Which statement describes the properties of hydrochloric acid? Remember that hydrochloric acid is a very strong acid. So let's see one by one each of the options. Carbon dioxide is produced when limestone reacts with HCl. Yes, that's right. Whenever acids react with the carbonates, limestone is a carbonate, right? Calcium carbonate. So carbon dioxide will be produced. So option A is correct over here. We don't have to look for other options. Let's see question 32. Which statement about dilute sulfuric acid are correct? First, it turns red litmus paper blue. Wrong. Okay. It reacts with magnesium oxide to form magnesium sulfate and water. Yes, that's right. Sulfuric acid can react with magnesium oxide and then it will form a salt and water because it's a neutralization reaction. Let's see third one. It reacts with magnesium to form magnesium sulfate and carbon dioxide. That's wrong. Whenever acids react with the metal, they produce hydrogen gas. But here it's a sulfuric acid, so of course it will produce magnesium sulfate, but not carbon dioxide, right? So its pH is below 7. That's right, because sulfuric acid is an acid, so its pH will obviously be below 7. So we have which options are right now? 2 and 4. So that is option C. Let's see question 34. Which statement describe a weak acid? It is a proton acceptor. Wrong. Acids are always proton donors, so option C and D can be right. Now let's see for the weak. Weak acids always partially ionize. They don't fully ionize, so that's why option D is the right option. Proton donor and partially ionized. Question 35. Which statement about aqueous weak acid is correct? So they are asking about the weak acid. Again, weak acids are always dilute. That's wrong. So let's see another option. Weak acid dissociate fully. That's wrong. When a weak acid is added to blue litmus paper, it stays blue. That's wrong because it will change to red. When a weak acid is added to solid magnesium, effervescence is seen. Yes, that's right, because hydrogen gas will be produced. Whenever acids react with the metals, hydrogen gas is produced. So that's why we can see the effervescence. That's why option D is correct. Question 36. Chloric acid HClO is formed when chlorine dissolved in water. It is a weak acid. What is meant by term weak acid? That are partially dissociated into ions. So which option is right? Of course, D. It is only partially ionized in solution. Question 37. Which statement about a weak acid such as ethanoic acid are correct? First, it reacts with carbonate. Yes, all acids can react with carbonates. Second, it does not neutralize aqueous sodium hydroxide solution. Wrong, because sodium hydroxide is a base. So acid will of course neutralize it even if it is a weak or a strong acid. It turns red litmus blue, so that's also wrong. It turns the litmus red, not blue. So we have only 1 and 2 options that are right. Let's see for the fourth option. It is only partially ionized in aqueous solution. Yes, that's right. So option 4 is also right. So the second option is not right because it does not. That is wrong. It does neutralize. So which options are now correct? 1 and 4. That is option B. So option B is correct. Question 38. Which statement about aqueous ethanoic acid are correct? It can be produced by oxidizing ethanol. Yes, that's right. With potassium iodide. That's wrong. Potassium iodide is not an oxidizing agent. It's a reducing agent. And we have to produce ethanol by oxidizing. So we have to use potassium magnate, not iodide. So this option is wrong. Let's see the second one. It reacts with magnesium to produce hydrogen gas. Yes, that's right. Acid always produce hydrogen gas when they react with the metal. It has approximate pH value of 3. That's also right because it's a weak acid. So its pH value will be more than 2. So it produces esters called methanoate. That's wrong. Whenever it will produce the ester, the name will change. Same like ethanoic acid, it will change to ethanoate, not methanoate. So that's why this option is also wrong. So which the options we are left with? 2 and 3. That is option C. So option C is correct. Question 39. Which equation represent a solution of ethanoic acid in water? So because it's an acid, so it will release the proton. And second one is that ethanoic acid, it's obvious from the word ETH. So ethanoic acid means it will have 2 carbon in its compound. So 2 carbon, of course, not here. We have just 1. So A and B options are not right. We are just left with C and D. So C and D, both options are same except for this reversible symbol. So reversible symbol is right for this equation. So because when weak acids dissociate into ions, it's a reversible reaction. That's why option C is the correct option, not the D one. Question 40. Ethanoic acid is a weak acid. Hydrochloric acid is a strong acid. Which statements are correct? Let's see one by one. Ethanoic acid molecules are partially dissociated into ions. Yes, that's right, because it's weak. 1 mole dm cube of ethanoic acid has a higher pH than 1 mole dm cube of hydrochloric acid. Yes, that's also right because acids always have a lower pH. The stronger the acid, the lower will be the pH. So because ethanoic acid is weak, so its pH will be higher than HCl. Let's see option 3. Ethanoic acid is always more dilute. That's wrong. The weak or strong has nothing to do with the dilute or concentrated. I already have informed you this one. So this option is wrong. Quote, ethanoic acid is a proton acceptor. Wrong. Even if it's weak, it is still a proton donor because it's an acid. So we are just left with statement 1 and 2, that is A. So option A is correct. Question 41. Aqueous ethanoic acid is a weak acid. Aqueous sodium hydroxide is a strong base. Aqueous ethanoic acid is neutralized by aqueous sodium hydroxide. Which statements are correct? So let's see. First statement, aqueous ethanoic acid accept proton. Wrong. It's an acid. It will donate proton. Let's see option 2. The aqueous ethanoic acid usually fully dissociate into ions. Again wrong because ethanoic is weak, so it will partially dissociate. Aqueous sodium hydroxide is fully dissociated into ions. Yes, right. The reaction produced salt and water, of course, because it neutralized, so its production will be salt and water. So we are left with option 3 and 4 that is right. So option D is correct here. Question 42. The concentration of hydrogen ions in 100 centimeter cube of 0.1 mole per dm cube of HCl is higher than the concentration of hydrogen ions in 100 centimeter cube of 0.1 mole per dm cube of ethanoic acid. Okay, the concentration is higher, right? So which statement explains this difference? Ethanoic acid is an organic acid that has nothing to do with the concentration, right? Okay, and then ethanoic acid has a lower pH than HCl. That's wrong. Ethanoic acid, of course, have a higher pH. Ethanoic acid is partially dissociated. Yes, that's right. That's why the hydrogen ions are less in the same concentration. Okay, the concentration of hydrogen ions is less. Why? Because ethanoic acid is partially dissociated. So option C is correct. Okay, let's see another question. 4 different acids are dissolved in water. Which beaker contains the most concentrated strong acid solution? So first of all, we have to find the strong acid and also that is concentrated. If you look at the option A, all of the ions are fully dissociated. So it means it's a strong acid. Let's see for the option B. You see HY we still have in the form of compound and then it is also dissociated into ions proton and Y negative. Can you see over here? Yes. So it means it's not fully dissociated into ions. It's partially dissociated because we can still see the compound HY. Here we can also see the compound HX and also the ions. So it means it is also partially dissociated. So B and C are rejected because they are weak acids. Let's see for option D. Option D is also right because you can see that all the ions are fully dissociated. So these both of them, A and D, are strong acid, but we have to find the concentrated one. So if you look for the option A, it has more number of ions compared to that of the D. So it means A is more concentrated. So option A is correct. Question 44. The equation represents an equilibrium in aqueous ammonia. How does aqueous ammonia behave in this reaction? If you look at the reactant, we have 3 hydrogens, but in the product, the same ammonia is changed to ammonium ion. It has gained the proton, so it's a proton acceptor. And proton acceptor is always a base. So ammonia is a base, but not a strong one. It's always a weak base. So that's why option D is correct. Question 45. A gas is escaping from a pipe in a chemical plant. A chemist tests this gas and finds that it's an alkaline. What is this gas? Okay, so if this is an alkaline gas, of course, it will be ammonia because ammonia, we already have this, find that ammonia is a weak base, right? Whenever it dissolves in a solution. So it means the gas is also basic in nature, ammonia. Whereas chlorine, it's acidic in nature. Hydrogen, it's neutral, whereas sulfur dioxide is also acidic. So option A is right. Question 46. Which gas is produced when ammonium chloride is warmed with aqueous sodium hydroxide? Obviously, it will be ammonia. Whenever the ammonium salts react with a base, ammonia gas is produced. Okay, so option A is correct. Let's see question 47. Information about the solubility in water of 4 oxides is shown. Which oxide, when added to water, gives a solution with a pH less than 7? So if the pH is less than 7, it means that oxide should be acidic in nature, right? So let's see which oxide is acidic here. We have only one option, that is nitrogen dioxide, and that is made up of non-metal. All of them are metals in nature, right? So that's why this is the only one that is acidic. So option A is right, because acidic oxides are made up of non-metal. Question 48. The oxide of two elements X and Y are separately dissolved in water and the pH of each solution is tested. Which information about X and Y is correct? If you look for this one, X has a pH of solution 1. Right? It means it is acidic in nature. So the oxide of X is acidic in nature because the pH is less than 1. So can you find over here? Yes, option A and B can be right because the oxide is acidic for X. For Y, it's basic. Yes, because the pH is more than 7. So if it is basic, then it means Y is made up of metal. So Y is made up of metal and X is made up of non-metal. So option B is the correct option here. Let's see question 49. Some properties of four oxides are listed. Oxide 1 reacts with both acid and alkalis to form salts. So those oxides that can react with both acid and alkalis, they are called amphoteric oxide. Okay. Oxide 2 reacts with acid to form salt but does not react with alkalis. Those oxides that can react with acids are actually basic in nature. That's why they can react with acid and can neutralize the acid and form the salt. Okay. So that's why the oxide 2 will be basic in nature, whereas oxide 3 will be acidic in nature because it reacts with alkali but not with the acid. Oxide 4 does not react with anyone, acid or base, so that's why it will be neutral in nature. So now let's see where we can find amphoteric. We can find basic and then acidic and then neutral. So it means option B is the right option here. Question 50. Which statement about oxides is correct? Okay, let's see one by one. A solution of magnesium oxide has a pH less than 7. That's wrong because magnesium oxide is basic, so its pH should be higher than 7. A solution of sulfur dioxide has a pH greater than 7. Again wrong because sulfur dioxide is acidic in nature, so its solution will have a lower pH than 7. Magnesium oxide reacts with nitric acid to make a salt. Yes, that's right, because nitric acid is a strong acid and magnesium oxide is basic in nature, right? So basic and acid will react to form a salt. So option C is the correct option here. Let's see question 51. The position of elements W, X, Y, and Z in the periodic table are shown over here. Which elements form basic oxides? We already know that metals form the basic oxides. So, of course, the one that are metal, they will form the basic oxide. So, W, of course, group 1, basic. X is also basic, and this is a transition metal. Y, so it's also basic. So, W, X, and Y are the right answer. Option A is correct. Question 52. Element E is in the group 2 of the periodic table. Which row describe element E and its oxide? Element E, group 2, so it means it's a metal in nature, and the oxide will be basic. So, it's option B. Question 53. Only two elements are liquid at 20 degrees Celsius. One of these elements is shiny and conduct electricity. Yes, in the periodic table, we have only two elements that are liquid at room temperature. One is metal and the other one is a non-metal. And the metal is actually because it's shiny and it conducts electricity. So it means they are asking about the metal, that is mercury. So this suggests that this element is a metal and therefore its oxide is basic oxide. So option B is the right option here. Let's see question 54. Element X forms an oxide that neutralizes sulfuric acid. So it means this element X is basic in nature. It's a metal because it can neutralize sulfuric acid that is acidic. Which row described X and XO? So X is a metal and the nature of the oxide will be basic. So option B is correct. Okay, which oxides are basic? Again, those oxides that are made up of metal, they are basic in nature. Calcium, metal. Sodium is also metal. Iron is also metal. So option A is correct. 1, 2, and 3. 56. Basic oxides are neutralized by acidic oxide. Which element forms an oxide that neutralizes calcium oxide? So calcium is basic in nature, right? So it means we have to find the oxide that is acidic in nature. Hydrogen form a neutral oxide. Which neutral? Of course, water, right? It's neutral in nature. Water is magnesium oxide, sodium oxide. Both are metals, so it will be basic. Now we are just left with one acidic oxide, that is sulfur, because sulfur is a non-metal. So option D is correct. 57. Which of the following are the properties of oxides of non-metals? So non-metals always form acidic oxides, and acidic oxide will be, of course, covalent in nature. Why? Because oxygen is also non-metal. And non-metal always form a covalent bond. So A option is right. Question 58. Element X forms an acidic covalent oxide. Which row shows how many electrons there could be in the outer shell of an atom of X? So we already know that element X is a non-metal because it's forming an acidic oxide. So non-metals usually belong to the group mode 4 or above 4. So 4 to 7 are non-metals. Let's see which one is 6 group and 7 group. So right, it means if they belong to group 6, they have 6 electrons in the last shell, and 7 means they have 7 electrons in the last shell. So it means they are non-metals. So we have to choose the option that has both 6 and 7 electrons in their last shell. So it means option C is correct. Question 59. Which elements form an acidic oxide? That's simple, sulfur, because all of them are metals. So only sulfur is a non-metal. So this option is correct. That is B. Question 60. Which element form an oxide that react with an aqueous solution of a base? So for base, it means it should be acidic in nature. And we have only one acidic oxide here that is made up of sulfur. So option B is correct. Question 61. The diagrams show one period of periodic table. Which two elements form acidic oxides? So they should be non-metals, right? So from carbon to fluorine, anything that is from carbon to fluorine, that will be the right option. So we can see over here carbon and nitrogen. They both are non-metals, so that's why they will form the acidic oxide. Carbon dioxide, that is acidic. Nitrogen dioxide, that's also acidic in nature, so option C is correct. Okay, let's see question 62. Nitrogen oxide, NO, and carbon monoxide are all non-metal oxides. They do not react with acid or bases. Which statement is correct? So if any oxide that's not reacting with acid or base, it means it's a neutral oxide. So option D is the right option here. Let's see question 63. 4 different gases are passed through the apparatus shown. Which gas has no effect on either piece of the litmus paper? If the gas has no effect, it means it's neutral in nature. So we have to find the gas that's neutral in nature, and hydrogen gas is actually neutral in nature. So that's why option D is correct. Which substance is neutral oxide? Okay, neutral oxide means this option should be carbon monoxide because carbon monoxide and nitrogen oxides are actually neutral in nature. So option B is the correct option here. 65. Which row describe whether an amphoteric oxide react with acid and bases? Yes, amphoteric oxide react with both acid and bases. So option D is correct. Question 66. 4 solid oxides are added to dilute HCl and aqueous sodium hydroxide. Which row describe an amphoteric oxide? Again, they should react with both. So that's why option A is the right option here. Question 67. Which statement about amphoteric oxide is correct? They react with both acid and bases. So option C is the right option. Question 68. Which element form an amphoteric oxide? Remember that there are some metals that form amphoteric oxide, not non-metals. And among those metals, one is aluminium, the other one is zinc, and the third one is germanium. You need to memorize this one, okay? So these three usually appears in the exam. So option A is the right option here because aluminium will form the amphoteric oxide. Question 69. Which oxide is classified as an amphoteric? Again, option A, aluminium oxides. Which type of oxide is aluminium oxide? Again, it's B. Option B is right, amphoteric. Which oxide is amphoteric? Again, option A is right, aluminium oxide. Germanium oxide is a white powder. Germanium oxide reacts with HCl. Germanium reacts with aqueous sodium hydroxide. So it means it's reacting with both, right? So it will be amphoteric. No need to read the other option. They are just asking for the type of the oxide. So that's why option B is the right option here. Zinc oxide is an amphoteric. Which row describe the reaction of zinc oxide? Of course, it will react with both acid and bases. So option A is right. Question 74. Zinc oxide is an amphoteric. Which type of substance will react with the zinc oxide? Both acid and bases. So option A is right. Zinc oxide is amphoteric. Okay, zinc oxide is added to excess dilute HCl. It's also added to aqueous sodium hydroxide. Which row describe the observation made in these reactions? Of course, it's a neutralization reaction. So we will get the salt, right? Salt and water. So we will see the colorless solutions that will be formed. So option A is the right. And also in sodium hydroxide, we will again see the colorless solution. So option A is correct. Question 76. In which row the oxides correctly identified? So acidic should be made up of non-metal. Let's see, magnesium, it's a metal. Magnesium, again metal. Sulfur, that's right, it's a non-metal. Carbon dioxide is also a non-metal, yes, so they both are acidic in nature. Let's see for this option. Calcium oxide, yes, it's made up of metal. Magnesium, it's also metal. So these are basic oxide and these are acidic. So option C is right. Question 77. Which row describes zinc oxide and calcium? Zinc, of course, it's amphoteric. And calcium, it's a basic. So amphoteric basic, option D is the right option here. Question 78. Carbon forms two oxide, carbon monoxide and carbon dioxide. Which row describe these two oxides? Carbon monoxide, of course, it's neutral in nature, and carbon dioxide is acidic. So neutral and acidic. Option C is right. 79. Which type of oxide are carbon monoxide and aluminium oxide? So carbon monoxide, of course, neutral, and aluminium oxide, we know it's amphoteric. So neutral and amphoteric. Option C is right. Okay, let's see question 80. Which statement about carbon monoxide and aluminium oxide is correct? So carbon monoxide, we know that it's neutral in nature, and aluminium oxide is amphoteric. So where we can find, okay, option D is the right one, because carbon monoxide is neutral and aluminium oxide is amphoteric. Let's see question 81. Oxide 1 is a solid that reacts with dilute HCl. Oxide 2 is a gas that reacts with sodium hydroxide solution. So now we have to look for the oxides. This one is basic in nature because it's reacting with an acid. And this one should be acidic in nature because it's reacting with a base. So now let's see where we can find the basic one. So calcium, yes, it's basic. Magnesium, also basic. Nitrogen dioxide, sulfur dioxide, they both are acidic in nature. So it means only option A or B can be right. Now let's see for the oxide 2. Oxide 2 should be, if you see here, it's reacting with a base. So it means it should be acidic in nature. Magnesium oxide is basic. So it means nitrogen dioxide. This option is right because nitrogen dioxide is acidic in nature. Option B is correct. Question 82. X and Y are the oxides of two different elements. X reacts with water to produce aqueous solution Z. Okay, so now whenever the oxide will react with the water, it will produce a solution. And this solution is changing the universal indicator blue. So if it is changing to blue color, it means it's alkaline in nature. Okay, this solution is alkaline in nature. It means it is made up of basic oxides. So X is actually a metal. Let's see now for this one. So we already know X is a metal and it has a basic oxide. Now let's see for this one. An aqueous solution of Y react with sodium carbonate to produce carbon dioxide gas. So whenever acids react with the carbonates, they produce carbon dioxide gas. So it means the solution of Y is acidic in nature. It means Y is an acidic oxide and Y is a non-metal because non-metals form the acidic oxide. So X is the oxide of a non-metal. That's wrong. X is the oxide of a metal. Yes, that's right. X is the oxide of the metal and Y is the oxide of non-metal. So option C is right. Let's see question 83. Four statement about the reactions of oxide with dilute HCl and with aqueous sodium hydroxide are listed. Which statements are correct? Let's see one by one each statement. Aluminium oxide. It's an amphoteric oxide, okay? So it reacts with both dilute HCl and sodium hydroxide. Yes, this statement is right. Calcium oxide react with both dilute HCl and aqueous sodium hydroxide. Wrong, because calcium is basic, so it will only react with HCl, not with sodium hydroxide. Copper oxide react with dilute HCl, but not with aqueous sodium hydroxide. Yes, right, because copper is basic. Copper oxide is basic in nature, so it will only react with the acid. 4. Sulfur dioxide does not react with either dilute HCl or aqueous sodium hydroxide. So only neutral oxide cannot react with the base or acid. Sulfur dioxide is not a neutral oxide. It's an acidic one. So this option is also not right. So now we are just left with which options? Option 1. And let's see about this one. Option 3. Yes, so 1 and 3 are right. So that is option B. Question 84. Which statements are properties of an acid? First, it reacts with ammonium sulfate to form ammonia. Wrong. Only bases react with ammonia salt to form ammonia. Turns red litmus blue. Again wrong. It turns it into red, not into blue. So both options are wrong. So that's why D option is the correct option. Okay, let's see question 85. Sulfur dioxide is bubbled through water containing litmus, which will describe and explain what happens to litmus. So the litmus changed to red. Yes, why it changed to red? Because sulfur dioxide is acidic in nature. It's an acidic oxide made up of non-metals. So non-metals oxides are always acidic in nature. And that's why it will turn it into red. So option C is the right option here. Let's see question 86. Butanoic acid partially dissociate in aqueous solution. It means butanoic acid is a weak acid. Which row about butanoic acid is correct? First, the pH. We'll look at the pH of the butanoic acid. It should be lower than 7. So it means A or B option can be right. 3 option is also right. 5 option is also right because it's for the weak acid. Now let's see for the effect on phenolphthalein. So the effect of the acid on thymophthalein will be it turns it into colorless. Okay, not the blue one. Blue, it will be changed by the alkaline solution. So this is acidic solution, right? Ethanoic acid, aqueous solution will be acidic. So that's why the turn colorless is the right option. So we can choose the option B. That is correct. Question 87. Methyl orange is added to dilute HCl and aqueous sodium hydroxide. What is the color of methyl orange in each solution? So you have to memorize this one. There is no concept behind it. You just have to memorize the colors. Methyl orange is actually orange in color, but when it is added into acidic, okay, it will change into red color. And when it will be added into alkaline solution, it will change into yellow color. So red and yellow, these are the right option. That is option B. Okay, let's see question 89. Which substance turn methyl orange red? Of course, it should be acidic in nature. So where we can find the acid, ammonia is not acidic. Dilute HCl, yes, it's acidic in nature. So option B is the right option here. What is the color of thymophthalein in dilute HCl? Again, it should be colorless because thymophthalein gives no color in the acid. So D option is the right. A few drops of methyl orange are added to a reaction mixture. During the reaction, a gas is produced and methyl orange turns from red to orange. What are the reactants? So if you see the methyl orange color is actually orange. But when they added it into a reaction mixture, the color was red and then it changed to orange. It means that there was a neutralization reaction, but instead we had acidic in the solution. So we have to find first the acid solution, that is here, dilute HCl, right? Dilute HCl here. So option C or D can be right. And then we have magnesium because they say a gas is produced. So only when the HCl will react with the metal, it will produce a gas that is H2, right? But if the HCl react with sodium hydroxide, we will not get a gas. We will just get a salt and water. So that's why option C is the only right option here. So option C is correct. Question 92. Which statement about acid and bases are correct? An acid react with the metal to give off hydrogen, right? Okay, whenever acid react with the metal, they always produce hydrogen. Second, a base react with ammonium salt to give off ammonia. Yes, that's also right. An acid react with carbonate to give off carbon dioxide. That's also right. Only acids, whenever they react with carbonates, they give carbon dioxide gas. Number 4, alkaline solution are orange in methyl orange. That's wrong. They are yellow. So 1, 2, and 3, that is option A is correct. Question 93, solution Q is warm with ammonium chloride. In a separate experiment, solution Q is added to methyl orange. Which observation shows that solution Q is basic? Okay, now let's see one by one. If solution Q is basic and it reacts with ammonium salt, it must produce ammonia gas. Okay, so a gas is produced. So option A or B can be right. Now let's see the second experiment. So when it is added to methyl orange and if it is basic, it should change the color to yellow. So if it turns the yellow, it means that is basic in nature. So that's why option B is the right option here. Okay, let's see question 94. Hydrogen iodide is dissolved in water. Which row describe the final color seen when the solution is tested with damp red litmus paper and the acidified aqueous potassium manganate? Because in the solution, you can easily see here that we have protons. So when we have protons in the solution, it means the solution is acidic. So that's why the damp red litmus paper will remain red. So option C or D can be right. Now let's see about the color of acidified aqueous potassium manganate. Whenever aqueous potassium manganate will react with hydrogen iodide because it's a reducing agent and potassium manganate is a oxidizing agent, this is a redox reaction. Now during the redox reaction, potassium manganate will change its color. So the purple color of potassium manganate will change into colorless. Okay, but we will not choose the option of colorless. Why? Because in the solution we have iodide ions and at the end we will get iodine. So iodine always give brown color in the solution. So that's why the color of the solution will be brown. That's why option C is correct. Let's see question 95. The diagram shows an experiment. A small volume of aqueous P is poured onto solid Q and the tap of the funnel is closed. Which pairs of substance cause the syringe to fill with the gas? So we have to see the reactants that can produce the gas in the product. So let's see one by one. First of all, we have nitric acid and magnesium. Remember that whenever metals react with acid, they always produce hydrogen gas. So that's why option A, B, C, all of them are correct. Now let's see for HCl and copper. Again, we have acid and a metal. Problem here is that the copper don't react with the acid. So that's why there will be no gas production or no reaction will take place. So that's why option C is correct here. Let's see for this one. Sulfuric acid and sodium carbonate. Whenever acids react with carbonate, they always produce carbon dioxide gas. So again, option C is the right option here. Let's see question 96. Which statement about sulfur and its compound is not correct? Option C. Sulfur form a basic oxide. That's obvious because sulfur is a non-metal, so it will not form a basic oxide. It will always form an acidic oxide. So that's why option C is correct. We don't have to look for other options. So this option is not the right one. Okay, let's see question 97. Aqueous sodium hydroxide is added to solid Q in a test tube. A gas is produced which turns damn red litmus blue. What is Q? Okay, so the gas that will be produced, we have to check that gas should be alkaline in nature. So if we look over here, we have aluminium, ammonia, ammonium chloride, and sodium nitrate. So if aluminium react with sodium hydroxide, we are not going to get a gas. Only whenever ammonium chloride, the ammonium salts, whenever react with the alkaline solution, they produce ammonia gas. And ammonia gas is alkaline in nature. That's why it changed the color of the litmus paper to blue. So that's why we have to choose the option C, because ammonium chloride will react with sodium hydroxide and will produce ammonia. So solid Q is actually ammonium chloride. Option C is the right option here. Let's see question 98. Ammonia dissolve in water to form a dilute solution of ammonium hydroxide. The reaction is reversible and exists as an equilibrium mixture. Which statement about the mixture is correct? Okay, now let's see one by one each of these options. All of the ammonia and water molecules have turned into ions. That's wrong because ammonia is a weak base. So it will not be converted all into the ions. So it will be partially dissociated into ions. That's why this option is wrong. Option B, the ammonia and water molecules have stopped changing into ions. Wrong because it's a reversible reaction. So it will take place continuously. It will not stop. The concentration of the ammonia molecules and ammonia ions are always equal. Wrong. Because in the reversible reactions, the reactants and the product concentration is actually constant but not equal. So that's why we cannot choose the word equal here. The rate of the reaction will be equal, but the concentration will be constant, not equal. Let's see option D. So now we are left with option D. So that's the right option. Let's see this one. The rate of formation of ammonia molecules is equal to the rate of formation of ammonium ions. As already discussed, the rate will be equal of the reactant and the product formation, but not the concentration. So that's why this option is right. Option D is correct. So these are all questions related to chapter 11. I will see you in the next video. Up till then, bye-bye. Thank you.